So hello guys, welcome to Mechanical Design Hub. Please subscribe this channel for mechanical design related, mechanical skill related, job related and profession related videos. So let's go to our topic. Today we are going to make a structural analysis of a hydraulic crane boom, that is mainly the main boom. So we have just made one hydraulic crane main boom in Solid Edge software. So let's go to the topic. Here you can see that we have already designed a one main boom, that is hydraulic main boom. You can see that there is one first cylinder portion, pinion portion, second pinion portion, third pinion portion. There is the one hook portion, and here we have just put the main lifting cylinder here, and there will be the rotating cylinder and blah blah blah. In our future video we have just make one hydraulic crane. So this is the model. Now we are going to analysis. For the analysis part, we have designed it in the the solid edge part portion. Here we have to give the material. Here mainly the steel is the steel, structural steel. The density is 7.85 gram per kg per meter cube. So this is the we have just defined the material portion. Then first go to the simulation, then go to the new study. When the new study portion come, then click the linear static and the mesh type is tetrahedral, then click OK. After that we have to define this met part to the we have to define this part for the simulation. Then go to the define, as we have just made it in part portion, so automatically the whole part selected in defined portion. Please click in the tick portion. If the main boom part, the front portion of the main boom, we have just give the force in the first portion. So if the uh, existing the other things which we have to lift by this portion, that is the weight will be 14 ton, then you have to change the 14 ton force into the meter millinewton force. So I have assumed that here the force, the weight I have to lift, or I have to lift, that is 14 ton. Then you have to change the force 14 ton weight into the millinewton force. Okay, we have just convert it. Then go to the this portion xyz component. Then you have to give the value of the force in z portion. So if we make the 14 ton, um, 14 ton, three, if we make give the 14 ton weight, then that convert to 14.4 ton to such 14144 into 10 to the power 6 millinewton. Okay, we have just give this force value here. We have give the force value here. Then we have to fix the other parts. Then go for the fixed part, go to the fixed portion and select these uh, holes which are for the other pinion side. So these we have just fixed this part. Then we have just fixed this part. Then go for the mesh portion. For the mesh portion we have to give the smaller mesh size. Then click on the mesh portion. So automatic the mesh has been done. After the meshing we have to solve that part. So please wait for the machine. You can see that the machine has been generated. After that go to the solve option. So it takes some time for the solving, so please wait for that. After that, I will show how to generate reports and how to know the displacement, the stress generating in the boom part. So here you can see that for 14-ton load, uh, in this how the deformation has been done. I have just the force value to this part. So here the deformation has been done. For if we change the force direction, please wait, I am just going to change the force direction here from this. Here you can see the force. Here I have to give the force value in a right way. 4. uh, Now I have just give the force value. Please wait, here I have to change the direction also. Direction also you have to just flip the direction. That's okay. Now if we go for the solve again, the right solve will be happen. Please wait for the result. It takes some time for the solving. Please wait for that time. Here you can see that for to lift 14-ton weight, the deformation has been done in this way. Here it is showing the stress for von Mises stress. Here the stress, you can see that the maximum stress are going to happen in this portion, that is around 270 731 megapascal. For so there is very much probability for the fracture portion of this part. After that, if we see the displacement, you can see the maximum displacement happened here. Okay, so in this way you can see the displacement here. And the other part is, if you go for the display option and for the maximum and minimum for the stress portion, you can see the maximum nodal point, the maximum deformation and maximum lower deformation value here. And other thing is, if you want to generate a report, it automatically creates some report. Here just click on the report portion and just from as the input data, then automatically they have generated the report. In this way you can make a analysis of a crane boom. So please comment in this portion for many videos, and in future videos I shall upload more crane designs and other things. So thank you all, and please comment and watch my all videos. Thank you all.